Hi, welcome to another mini lecture. Today's topic is circumference of a circle. So for sure you have seen this problem a long time ago. Let's just go ahead and review what the issue is here. So first problem, a radius of the circle is given, and the question is what is the circumference of the circle. So you remember circumference, let's show it by C, and radius r, and circumference is 2 pi r. So all that is left to find this particular case, 2, it says for pi take 3.14. Don't add or subtract or anything to the number of digits, just 3.14. And well, the radius we are being told is 3. You're just supposed to multiply them, and then it says do not round. So it insists for some reason just leave this as it is, multiply it and do not round it, and enter your answer here. And also make sure you include the unit in your answer. Most math problems do not bother with the units, but you need to get used to that because you have to take courses in sciences, physics, engineering, biology, whatever it is. Most problems have a topic related to measurable quantities, and measurable quantities always come with units. And here you see the unit, it's the radius is measured in feet, and here there will be some place for you to pick up a unit, and there has to be in feet. Okay, so that was easy enough. So just multiply this thing. There's going to be a calculator here, you just use that and pick up the answer without changing digits, and enter it in your response field. Slightly different version of the same problem. Again, we have a circle. This time it has a diameter, and we are asking for the same thing. So the diameter is given, and we are looking for the circumference, and circumference, you know, it's pi times d. Simply the diameter is twice the radius, and all that you have to do is now take 3.14 times the diameter, which is given to us as 22. Here's the quantity, and then the circumference that you get is what did I do? 3.14. I didn't make that mistake here, did I? Okay, so you multiply it and then you enter the answer. And of course, again, the question is what's the unit, and here's your unit. Okay, well, that's a bit of too short of a lecture. Let's talk a little bit extra. We are all done with the problem that's in your in front of you. If you want to just move on to the next topic, be my guest. But here the prize is this number pi. Pi has been with humanity since God knows 3,000 years ago. So what is pi? So this is the additional lecture, it's optional. If you want to move on, that's perfectly fine. What's pi? Well, you learned from high school pi is 3.14. That's what's given up there, but that's not where it stops. It has been a preoccupation of humanity to try to calculate pi, and it has become a fashion these days that every time a new computer comes online, they go ahead and use it to measure, to calculate pi to 1 trillion digits. So this thing keeps going on with no simple pattern for anybody to just use and to write the remaining digits. Quite advanced software can be used to find these digits, but where does pi come from? So pi is, as we wrote up there, is the ratio of the circumference to the diameter of the circle. So if you have a circle, it has a circumference, it has a diameter. Ratio of these two is pi. How can we see that it is 3 point something? So from about 2,500 years ago, people started to work in this topic, and one of the first things that they noticed is that, well, if you have a circle and you use this radius, and second time, a third time, fourth, fifth, and sixth time, you come back to where you were. So you can make a hexagon to fit inside your circle, and if your radius is 1, well, now you have a diameter of 2, and the circumference of this hexagon is 6, and 6 divided by 2 is going to be 3, and that's a recovery of this first digit here. Pi is going to be more than that, because you have to take the circumference of the circle. You have to take all of that, calculate all of that, and divide by twice the radius to find out pi. And in fact, that's the project, the very first project people used to figure out what pi is, was to start from here and say, okay, let's go ahead and take this hexagon and divide every one of these triangles into two equal triangles. So we do this triangle, and then this one, and then this one, and this one, and this one, and this one, and now we have a shape with 12 sides. So here is number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Actually, with the trigonometry that we are going to learn at the end of the semester, you can go ahead and find out what is the circumference of that 12-sided polygon. Okay, that 12-sided thing is closer to the circle than the hexagon was. So you can take that and divide it by the diameter, and then come to a better approximation of what the pi is, and perhaps get maybe 1 digit here. And then what do you think you're going to do next? Take that 12-sided polygon and subdivide each of its triangles, make gradually much thinner triangle, and now you have 24 sides. You can find out the side of that triangle, that base that is here, add it to itself 24 times, so you have to multiply that by 24, add them all up, divide by 2, and then you're going to get a better approximation for the pi. And keep repeating this, that is, keep subdividing these triangles into 2, get a polygon with much more sides. So we start with 6, and then we go to 12, and then 24, and then 48, and 96, and I think the ancient Greeks did go as far as 96. It's going to tax your patience, but surely enough, it's going to give you an approximation for pi. Well, you can continue this topic and get better and better approximation for pi. If you are interested in doing something like that as a little side project, you can let me know. We can talk about it. Here is a little demo that also tries to explain something else, which is the formula for the area of a circle. You know from high school again that the area of a circle is pi r squared. While we are doing this subdivision into this thin triangles, we can actually come across the formula for the area as well. Here, let's go ahead and see here. Let me see if I can find for you. Here is a pizza. I'm sure I've dealt with the issue of cutting it up and putting it in a box that takes perhaps little less room. Here it subdivides it into 8 slices and rearranges it until it looks like something like a rectangle. Kind of a funny looking sides, little bumps and curves on it. But if you apply this idea, you can actually get the formula for area of a circle. Let's go back and see how it works. So what did we see there? Let's take that picture. So it was a pizza that was sliced into 8 slices like this, and they were arranged next to each other in an interesting way. One perhaps this way, and the next one, let's draw that next one a different color. And then again, one pointing up, another one pointing down. I feel like going and eating a slice of pizza, but I don't have pizza. Here is, my drawing is not as good as that demo, is it? So now we have and finally this is the 8th. Now if we go ahead and do a subdivision, meaning take this slice and divide it by 2, and then divide by 2, and then divide by 2, and so on, our slices are going to become very skinny. So we are going to have one slice like this. I'm not going to try to draw all of them, and then another one upside down, and then you go on. So this was 8. If you subdivide them into 2 and do 16, you're going to do like that. And if you do 32, and if you do 64, and keep going, what happens is that this shape is going to gradually become like a perfect rectangle. The interesting thing is that as you go on, this becomes a perfect rectangle. Well, what is the side of this rectangle? This one is going to be R. This is R. This is R on the other side. What are these? What's the name of something like this? Well, that's going to be half of the perimeter of the circle. So the other half is down here. Half up there, half down here. Well, we had said the circumference is 2 pi r. Half of it is going to be pi r here, and the other half is going to be pi r down here. The circumference is going to be pi r, half of it here, the other half down here. Well, when you're cutting the pizza and rearranging it like this, you are not eating any of it, are you? So what happens if you're not eating it? Well, how much pizza you had here, which is the area of the pizza, you still have it here, and then, well, you have it here too. The areas are the same. This area and this area are the same area, are same. Well, what's the area of a rectangle? Side times width. So pi r times r, which is what? Pi r squared. So that's one way to justify why the area of a circle is pi r squared. Okay, So let's go back and see what we said today. We just have a basic formula. Circumference is 2 pi r, or if you wish, circumference is pi d. And we went off on a tangent here and talked about pi and the formula for area and the idea of a subdivision. And I gave a little project to you guys if you want to start on that, and hopefully by the end of semester you have something to show me. Okay, let's go back and get ready for our next lecture. Until then, good luck and God bless.